This is a disproportionation reaction, also called as self-oxidation and reduction reaction, occurs mainly with aldehydes that do not have alpha CH hydrogen atom. However, there are some notable exceptions, just as isobutyraldehyde. We will explain this why this doesn't occur. Now, let us consider some examples that will undergo this reaction. So let us first take this molecule. Again, reaction will take place under strong alkaline conditions. One of the products here will be the reduced alcohol. Along with that, we will get the sodium salt of the acid. This is obviously your formylaldehyde. Okay. Next, we have taken benzaldehyde. So obviously the reduced molecule will be the alcohol, which is benzyl alcohol. Along with that, we will get the sodium salt of benzoic acid, or we can also say sodium benzoate. Next, suppose we have taken pyridine 2 carbaldehyde. So this one, once treated with 50% NaOH, will give you the alcohol and the sodium salt of picolinic acid. Okay. Few more examples. Just make one alcohol and the other one will be your acid. Okay. Also have furfuryl, that too treated with this, gives you the alcohol and the acid. salt. Okay. Now let us have a look at the mechanism for the reaction. So I'm just taking formaldehyde as the molecule to explain such a thing. Now suppose you are treating this with, so obviously the electrophilic carbon will be attacked by the nucleophile. Okay. Now at this step a hydrate attack can take place at the second molecule of the aldehyde. Okay, now this is your rate determining step, and so leads to the formation of the acid, the conjugate base of the alcohol. The proton of the acid is much more acidic than the proton of the conjugate base of alcohol, so here a proton transfer will take place from here to here, and that leads to the formation of the formate ion, and we also get a molecule of methanol. So the alcohol is the reduced counterpart and the acid is the oxidized counterpart. That is why this is called a disproportionation reaction. Now when the medium is highly basic, okay, it is highly basic, then another proton from the OH can be extracted and leads to the formation of this type of a dinegative ion. Okay, so if we consider the initial reaction in which two molecules of the aldehyde and one molecule of the base is involved, so we will say the rate equation to be dependent on the both the molecules of aldehyde and a single molecule of the hydroxide, but at highly alkaline medium the rate equation will be dependent on both the aldehyde molecules along with two molecules of hydroxide. So question regarding this may be asked in your competitive exams. So this is one more fact about the reaction. Now sterically hindered aldehydes and aldehydes joined to very electron rich donating groups, they do not undergo Cannizzaro reaction. Now, let us take some examples. Suppose I have given you something like this. Now here N is acting as a plus M group. So electron can be donated from here to the ring, which we can get relayed to the carbon of the carbonyl. So if this is happening, we can imagine another canonical structure like this, which reveals to us that such a form can exist, which means this particular carbon is not so electrophilic as we have seen in the other cases where this carbon can be attacked by a hydroxide ion. Okay. Next, another molecule again similar explanation. For this carbon to be attacked, it should be electron deficient. Okay, but if such a plus M is happening towards the ring, then we can imagine that it is not electron deficient, and so the nucleophilic attack will not take place. Okay, so something like this. All right. Now, an aldehyde, something like this, will not undergo Cannizzaro reaction because it is sterically hindered. By the occupancy of the orthochlorines. Okay. So at the initial point, one may think that such compounds, this and this, will undergo Cannizzaro reaction, but one has to remember, if there is a electron donating group present with these kind of aldehydes, then the electrophilicity of this carbon will be reduced, and so they will not undergo Cannizzaro reaction. Okay, next, let us take some examples, few more examples, which I am giving. We try to do it. So we had done till 5. Okay, now I'm giving you 6. Let's give it a try. And this is treated with OH 50%. So obviously my products here will be and something like this. Okay. If I have given and also my products will be the acid salt, and along with that the reduced product alcohol. Okay. Now, if I have given you two different aldehydes, okay, then such a reaction is known as crossed Cannizzaro reaction. So two different aldehydes, if they are given, we will be calling this as crossed Cannizzaro reaction. Okay. Let us check out some examples. Okay. Now here, this is question number 1. I have given you a benzaldehyde and a formaldehyde. Now we know that formaldehyde is more reactive. Why it is more reactive? Because there is no plus M effect happening from the phenyl, and apart from that, sterically less hindered. Okay. So from electronic point of view and also from the steric point of view, we know that formaldehyde is more reactive. So it is the carbon of the formaldehyde that will be attacked by the OH, and that means we will generate something like this, and the hydride ion transfer will take place from the formaldehyde to the carbon of benzaldehyde, which now means that we will be getting the formate ion by the oxidation of formaldehyde and benzyl alcohol as the reduced product. Okay. So similarly, you try this question. Again, along this I have given you formaldehyde. So using the similar logic as we have done above, obviously your product will be, this is your, will be giving you alcohol, and that will be giving you formate ion. Number 3, suppose you are given something like this. And something like that. Now you have to think at this point, which is more electrophilic carbon? Is it the carbon that is attached para to the nitro group, or is it the carbon that is attached meta, carbonyl that is attached meta to the carbonyl group? Okay, so we know from the para position minus M and minus I will be operating, and from the meta position only minus I is operating. So obviously it is this carbon that is more electrophilic, and obviously attack will happen over here. So if you give OH, OH will now attack this carbon. That would mean that this becomes that, and now the hydride ion will attack the carbonyl which is attached meta to the other nitro group. Subsequently, it means that we will get the para-nitrobenzaldehyde oxidized to acid, whereas the meta-nitrobenzaldehyde will be reduced to alcohol. So such questions can be given to you and you have to answer it. Similarly, I can give you questions like just using the same principle. I've given you chloro. Say in one I have given you group that is acting as a electron withdrawing group, and something like this in presence of OH. Okay, or I can give you CH2OH whole thrice CHO plus this one. Again, one has to use the similar logic, and obviously our products will be okay. This one will be getting reduced to alcohol, and formaldehyde will be forming formatine. Okay. Next we are doing intramolecular Cannizzaro reaction. Okay. Intramolecular Cannizzaro's reaction. Now this will happen when aldehydes, two aldehyde or more are present within the same molecule. Okay, so as I've said, this will happen where? Happens when two aldehyde groups or more are present within the same molecule. Suppose I give you something like this. Now this is your glyoxal. It is having aldehyde groups. Technically this is a 1,2 dicarbonyl. If you treat this with OH, so suppose this is getting attacked, that will open up. Now what happens is this becomes O minus, This is your OH, that is your H, this is your another aldehyde. Now hydride transfer will take place from here to here. That will open up. So one is now getting oxidized and another is getting reduced. Okay, now that was your red determining step. Proton transfer means this get converted to carboxylate. Okay, and that is both the hydrogens. So that is your product. Okay, next, if I give you obviously ketones are less reactive than aldehydes. So this will attack here, that will open up. Now that means this is your, so hydride transfer now takes place from here to the ketone. So the ketone now gets reduced, that is again your RDS. Proton transfer step will take place. This becomes your alcohol and that is your converted to acid. So whenever there is a ketone or aldehyde group is present, then we can always directly think that the aldehyde group gets converted to acid and the ketone will be getting converted to your alcohol. So you're keeping that principle in mind for such an example. Now this is your aldehyde and that is your ketone. So our answer will be what? Alcohol, and that is your acid. Okay. If two such aldehydes are present, just like the first example, one will be acid and one will be alcohol. Alcohol, another is your acid. Okay, so this is 1, this is your 2, that is your 3, this is your 4, number 5. I think this once came in IIT advanced exam. Just an extension of the problem 4 over here. So your products are, suppose this is your acid, and there will be your alcohol. So this is your, suppose, acid, and that is your alcohol. Okay, that is your answer. 6 can give you something like this. Let's keep using the same principle, acid and alcohol. So that is your acid, that is your alcohol. Okay. So this is all